Next, we'll hear from Sherman Lee of the Raven Protocol. Sherman is a longtime acquaintance of our mainframe founder, Mick Hagan, and we are very excited to hear what he has to share.
All right, what's going on, Decentralized Summit? I'm Sherman Lee, and thank you for that introduction. I'll be talking about AI and blockchain today. I know these are like the two buzziest words around the last couple of years, but I'm going to share with you why artificial intelligence and machine learning, it really needs to be decentralized. So a little bit about me. I'm the founder of Raven Protocol, where I work on decentralized and distributed deep learning. And we're creating a network of compute nodes that utilize idle compute power specifically for the purposes of AI training, where speed is the key. I'm also a partner at Zeroth.AI, where I invest in AI, blockchain, and deep tech companies. We have offices in Hong Kong and China, Bangalore in India, Tokyo in Japan, which is where we have also a strategic partnership with SoftBank's DeepCore to invest in and address the global issues of the power of AI. I always like to tell this story. I never thought that I would be working in the AI field. I grew up in Oakland, California, in a very rough neighborhood. The picture on the left was my local liquor store. This is where we bought snacks, drinks, sodas, ice creams, and all that stuff. And we would stop in every single day. But so would all the drug dealers on that street. Like sometimes at my own house, I would find crack rocks in the mailbox because like when the police patrolled around, the drug dealers needed to find a place to hide their stash, which was our mailbox. When all was said and done, they came knocking on my door looking for it later. And this was wild as a 7-year-old kid, the things that I just really shouldn't have been learning. But somehow I ended up getting into UC Berkeley. I studied computer science. I took classes on artificial intelligence and distributed computing. One of my first jobs was a machine learning, out of college, was a machine learning engineer at Yahoo. I was the first engineer on that team. I helped scale the content platform there to 600 million users. My area of specialty was clustering, and specifically on news article content. So if you've ever read a bunch of news articles in search, or you went down to the C-related articles at the bottom of any news article, you probably saw my work. But using machine learning on that content platform wasn't an easy task. It was actually kind of a hard feat. I worked with a team of about 25 research scientists, and we had 40,000 servers running Hadoop. It was literally my job to make machine learning scale in production, and I worked on this problem for about 5 years. This kind of technology is trapped inside of mega corporations like Facebook or Amazon, Google, Microsoft. Like the computing power, the data sets, the research, the technology. This was all hoarded for themselves. And AI today is totally centralized. It's mostly a privilege of large companies with really rich resources. These are companies that are able to hire expensive AI and machine learning teams. They're able to develop models which produce more data, which enriches their company's data sets, and it turns into this really vicious cycle. And it's resulted in large companies like Google, Apple, Facebook, Amazon, acquiring really unprecedented levels of knowledge and influence over like our daily lives. So like, can a small startup stand shoulder to shoulder with these kinds of giants? I had to find out the hard way. So that's me in the back with the double peace signs in 2017. I look happy, but this was a period of time in my life where I was just super stressed out. I was running an AI startup. User growth was coming fast. Costs exploded, and on AI training alone, we're being invoiced $5,000 to $10,000 a month from AWS, and that's a lot of money for like a small startup. And the training times were slow. Took about 2 weeks to train a 1 million image data set, and that just wasn't acceptable. And I thought that because I did machine learning at scale already at Yahoo, I could pull off some of those really difficult tasks. And I was in for a shock how incredibly hard it was for a company, a small company, without the big resources of like a big company has. Um, and like to really compete with those giants, we have to start putting the power of AI into the hands of the community. So in the last 5 years or so, we kind of made a bit of progress. In the first phase, there were advanced techniques in AI and machine learning that got open sourced. There's incredible work from AI researchers. The picture on the left are the forefathers of deep learning, and their work got into the hands of AI practitioners via numerous papers that they published. In phase two, that work from the AI practitioners got into the hands of software developers via implementations on GitHub. And this led to a chain of events where well-structured and optimized machine learning and deep learning frameworks were created. So these are things like Torch, Tiano, MXNet, CAF, and of course TensorFlow. And that was just the beginning. It was a period of time which I called an MVP. It was a validation that there was a huge demand for companies to leverage existing AI and machine learning frameworks. And living through all that is what makes me really believe that blockchain will transform the entire AI industry. Because if we successfully decentralize three key things, like how we get the training data, finding the research algorithms, and leveraging compute resources, we'll be able to live in a world where AI and machine learning models are getting better, faster. And this could be done without the rich resources of a large company. Individuals in the AI community and small startups will have access to this power and create applications that just would never have seen the light of day. Blockchain enables a decentralized AI training data. So like having enough data to train AI and machine learning models has been a never-ending challenge for everyone. Traditionally, only companies with a ton of users have access to those large data sets. So decentralization is a really good fit for getting more data sets into the hands of the AI community. And there's companies working on that, like Ocean Protocol and Quadrant, which reward users for supplying that data. And there's also companies like Effect.AI and Gems that are rewarding users for correctly labeling that data. And then blockchain also enables sharing of research algorithms and trained models. While data is the key in training AI and machine learning models, algorithms that run in a decentralized and distributed manner is what's needed to process that data. So companies like SingularityNet and Cortex, they have marketplaces where you can purchase trained models, other AI services, and use algorithms that are developed by other people in that marketplace. And then a blockchain enables the sharing of idle compute resources. So leveraging idle computing power really helps to run computationally intensive AI and machine learning training. And we all own idle compute power. You know, it's in our laptops, it's in our phones, and you should be able to earn money by lending that out. Like, you know, even all while attending this decentralized summit, you could literally get paid for watching these talks because your computer is just running. And companies like Golem or Perlin and Hypernet, they all have novel ways of leveraging idle compute power. And obviously, I'm one of the founders of Raven Protocol, where we're creating a network of compute nodes that utilize idle compute power for the purposes of AI training, where speed is the key. We have a very specific use case to perform fast AI training, allowing companies to iterate on their models quite quickly. And we discovered that our unique value proposition, which is that Raven performs AI training where speed is the key. We developed a completely new approach to distribution that speeds up a training run of 1 million images and takes that down from 2 weeks to a few hours. So existing deep learning distribution methods and frameworks, I'll call these the conventional methods, they've come a long way. But they still require gargantuan servers for the speeds at which the demand is increasing for AI. Data and model parallelism have been used to optimize this, but it really creates inherent latency in the network, and it's just not scalable beyond a certain limit. And at Raven, we solve latency by chunking the data into really small pieces, literally down to the bytes, maintaining its identity, and then distributing it across a host of devices with a call to action, which are the gradient calculations. This is a screenshot for the first time that we ever fired up the Raven network. Our proof of concept worked in a local dev environment, but to get this to work in production with external compute resources would require extremely hard work. So we had to start building our own framework. And like, to give you a bit of background, we simply couldn't build upon one that existed, as our approach was unique. Like the existing frameworks, they just had a different approach for calculation and data distributions, which couldn't have solved for our purpose. So we had to rewrite the foundation layer, which could support minuscule distribution over a distributed setup. And we do that with dynamic graph computation. So bear with me, this gets a little technical. So all the frameworks operate on tensors and are built on computational graphs as a directed acyclic graph, a DAG. And in most of the current and popular deep learning frameworks, including TensorFlow, the computational graph is just static in nature. However, there's frameworks like PyTorch, and it's dynamic, and that gives a lot more options to researchers and developers to fiddle around with their creativity and imagination of how they want to optimize things. And a major difference between static and dynamic computation graph is that in the former, the model optimization method is preset, and the data substitutes the placeholder tensors. Whereas in the latter, the nodes in a network, they're executed without a need for any placeholder tensors. So dynamic computation holds a very distinguishable advantage in cases like language modeling, where the shape of the tensors are variable during the course of training. The benefit of a dynamic graph is its concurrency. So like it's robust enough to handle the contributor node addition or deletion, which makes the whole Raven training sustainable. So like Raven is capable of eliminating that latency and scalability issues with both of those approaches. And thus, hence, distributing the training of any deep neural network and their larger data sets by getting rid of the added dependency on the model replication. And data is also sharded in smaller snippets. And in fact, the model is intact at the master node, and the heavy lifting is distributed in the tiniest snippets of data subsets over a network of contributors. And then the resulting gradients after those calculations that happen at the node or contributor end is then sent back to the master node. And this creates a ton of difference, as it's easier for calculations to pass through from machine to machine rather than creating multiple replicas of a complicated model, which most conventional methods do today. Um, I I know that was kind of a lot of stuff to wrap your head around. Um, but if you want to learn more about why AI machine learning needs to be decentralized, or if you want to learn more about the Raven protocol, just feel free to reach out to me or the team. In fact, if you do reach out, we'll send you 100 Raven tokens. Actually, we'll airdrop tokens to every single attendee of the Decentralized Summit if you email us with a subject, the need for speed. So the email is founders@ravenprotocol.com. I really hope you all enjoy the rest of the Decentralized Summit. Like every single event that Mainframe has put on has been top notch, and I always learn a lot from them. So thank you for your time.